This lesson is on identifying intervals of increasing and decreasing in a function. An input increases as the input increases, the output also increases, or as the input decreases, the output also decreases. In a graph, we are just looking for the slope to be a positive number. So that means from left to right, the slope is going up. A function decreases when the input increases, the output decreases. Or the opposite, as the input decreases, the output increases. So they are going in opposite directions. On a graph, we are looking for the slope here to be negative. So that means from left to right, our function is going down. A function is remaining constant when the slope is 0. So that means that we're going to have a horizontal line when the slope is remaining the constant. The graph shows the speed of a train that is traveling. Describe the behavior of the speed of the train. So there's no numbers, so all we have to say is that the speed of the train is decreasing because our graph is going down from left to right. During which intervals is the following graph increasing, decreasing, and staying constant? So we're going to talk first about when the graph is increasing. The graph is increasing when it's going up from left to right. So that is happening at interval 3 and at interval 4. The graph is decreasing when it is going down from left to right. That is happening at interval 2 and interval 6. And the graph is remaining constant when there's a slope of 0, which is happening at 1 and 5 because those are just horizontal lines. So we're not looking to see if it's linear or nonlinear, we're just looking to see if it's increasing or decreasing. Demi went for a run in a park. The graph represents her speed during her run. Describe the graph when the function is increasing, decreasing, and staying constant. So again, since there's no numbers, all we're just going to do is write a story to describe what's happening. So we could say that Demi's speed increases, which makes sense because she's starting her run. Then her speed remains constant. After it stays constant for a long time, she starts to slow down, meaning her speed decreases. Then her speed is constant at 0, meaning she is not moving or not running. So she must take a break. Then she increases her speed, remains constant again for time, and then she ends her run when she slows down again. Which graphs matches this description? So you have to go through the choices. The function is constant at interval 1. So that means at interval 1, it has to be a horizontal line. So I can get rid of A because it's increasing. For B, it's constant. For C, it's increasing, so I know that's not my answer. And for D, it's staying constant. So we're between B and D. The interval, or the function, has to be increasing at interval 2. So interval 2, it's increasing, and it's increasing for both of them. Decreasing in interval 3, decreasing, and decreasing, and increasing in interval 4. Interval 4, it's increasing there, but for D, it's staying constant. So D is out, so B is the graph that best matches this function, or this description.